All right, welcome you guys to our last section. So we talked about arithmetic sequences and series in 8.2, and now we're going to talk about geometric sequences and series. So the difference is that instead of adding and subtracting, we're multiplying and dividing. So in this one right here, let me go ahead and get my pen on. This sequence over here, you can see that we're multiplying by 2 to get from 2 to 4. And we continue to multiply by 2, right? 4 times 2 is 8. 8 times 2 is 16. Okay. So anytime that you're multiplying or dividing by the same thing every time, that would be a geometric sequence. Okay. Now, the thing that you're multiplying by is called the common ratio. So we use the letter R for that. So our common ratio would be 2 in this case. And the reason why we call it the common ratio is just like before with the common difference. If I take any two successive terms, so let's say I take the second term on top of the first term, I get 2. If I take the third term on top of the second term, I get 2. If I take the fourth term and stack it on top of the third, I get 2. And so actually a formula for the common ratio, if you come across a sequence where it's kind of hard to see, is you can always stack the second on top of the first. And honestly, it could be any of them, but it's just easiest to stack the second on top of the first, okay? So a ratio is a fraction, so they all have that common fraction. All right, now another thing to note about geometric sequences is we always phrase it or we always put it in terms of multiplication. So let's say you have some sequence where you're actually like dividing by 2 each time, okay? So we don't really talk about division. We don't really say divided by 2. Instead, what we would say, because we always have to frame it in terms of multiplication, is we would say that we're multiplying by a half. We're multiplying by a half, okay? So everything has to be in terms of multiplication. You can't phrase it in terms of division, okay? All right, so it says determine whether the following sequence is geometric. So it looks like we multiplied by 3 to get from 2 to 6. It looks like we multiplied by 3 again. It looks like we multiplied by 3 again. So we're going to give this one the thumbs up, right? Okay. So this is geometric since we are multiplying by the same number every time. The common ratio is R equals 3. Okay. All right, if we head over to this one, we can see that it looks like we multiplied by 3, but we did not multiply by 3 again. Okay, so this one is not geometric. Top of that, we could say even more. It looks like we're adding 4 every time. So this one actually would be arithmetic. Okay. This is not geometric. In fact, it is arithmetic with common difference. D equals 4. Okay, we're adding 4 every time. Okay, so over here, it said write the first 4 terms of the geometric sequence. Okay, so I always like to get my blanks ready. So 1, 2, 3, 4. And so we know the first term is -2, and we know the common ratio is 4, so we're multiplying by 4, which would give us -8. We're multiplying by 4 again, so that would give us -32. And then we're multiplying by 4 again. Ooh. So let's see here, 4 times 32. Okay, so -128. Okay. Now over here, we've kind of already talked about this. This is just a picture reminding you that there is a difference between a sequence whose domain is the positive integers and a function of x whose domain is all real numbers. We do not connect the dots because there is no 1.5 term, right? There's no 1.5 term. There's a first term, there's a second term, there's a third term. So we should only get values at positive integer values, okay? And those are the things that we found right now, okay? All right, let's go to the next one. Write a formula for the nth term of the geometric sequence. So that formula for the nth term was on this first slide. It's right here, kind of like hidden. So let's actually box this so you guys can find it better. That's going to be a big deal. Okay. A sub n equals a sub 1 times r to the n minus 1. Okay. So I'm going to go ahead and write it down. A sub n equals a sub 1 times r to the n minus 1. Okay, so we got to find all the things that we want. So we know the first term is 5. And it might be kind of hard to see what we're multiplying by to get from 5 to 4. So a couple things that you could do to remedy that is maybe don't look at the first two terms, okay? Maybe if I look from here to here, it'd be easier to see that to get from 4 to 16, I multiplied by 4. And then to get from 1 to 5, I multiplied by 5. So you can always look, later on in the sequence to see it if you can't see it at the beginning, okay? Another thing you can do is we said you always stack the second term, you always stack the second term on top of the first term. So if we did that, it would be 4 over 5. So a lot of different ways that you could go about getting the common ratio. In fact, you could probably see from here, we times 4 or multiplied by 4. And then from here, we multiplied by 5. So 4 over 5 must be the common ratio. Okay, so let's go ahead and substitute n here. So write a formula for the nth term. So a sub n equals a sub 1 times r to the n minus 1. That would be our formula. So now somebody could plug in any n they want and find any term in the sequence. Okay, number 5, find the sixth term. Okay, so let's go ahead and write down our formula. And let's get our pieces. So we know a sub 1 equals 10. We don't have the common ratio. We need that, right? Okay, we're missing that. But what we do have is we have the second term and the first term, right? So we can always stack the second on top of the first. So if we stack 12 on top of 10, we would get 6/5 as our common ratio. Okay, and we know the n. Once the sixth term, so n is going to be 6. All right, so a sub 6 equals the first term 10 times the common ratio of 6/5 to the 6 minus 1. So this is going to be 6/5 to the 5th. So I'm just going to punch this whole thing in my calculator, you guys. It's intended to be a calculator question. Holy moly, I got a big number. I got 15552 divided by 625. Okay. Now if you're struggling to use your calculator, you can always piece it out, right? If I have to do this, I have to do the exponents first because of the order of operations, right? But please excuse my drunk Aunt Sally. So I'd bring my 10 down and I would just tell my calculator to give me 6 to the 5th power. So I know the top would be 7,776. And then I would do 5 to the 5th power. And so I would get this, right? And if I'm going to be multiplying by 10, then all that's going to do is add over 1, right? It's just going to add a 0 to the top. And then you could put that in you could reduce that clearly by 5. So I'm going to divide by 5. Anything that ends in a 0, 5 goes in. Anything that ends in a 5 goes in. And this is only if you don't have a really good calculator, because some of you don't. You didn't get that Casio 300. Okay, and there it is, 1552. And 3125 divided by 5, 625. So the one I'm working with now isn't very good. I have the Texas Instruments 30X. And it's kind of a hard one to use in comparison to the Casio. And so you probably would want to do it all the way out. Okay. Another way you can do it, I'm not even going to go there because it's kind of terrible. Okay, it'll get you there, but we want to be smooth. All right, number 6, find R, A1, and an expression for the nth term. Okay, So the formula that we have actually generalizes even more. So if we want to generalize this even more, then you can make all the ones become the letter M. And what this does is it allows us to use the formula without having to know the first term. Now I can know any term. So in this case, this would be 4 would be my M, and this one would be my N, and I would plug them in. So I have the 7th term, and I have the 4th term. Okay. Always make sure that you have the bigger number here and the smaller number here. That way, when you subtract, you get a positive number. You don't want to have a negative number here. Okay. So it looks like we're going to get a sub 7 we have is 1920. A sub 4 is negative 240. I don't know R. So we would have to solve this. So it looks like we'll just be dividing by negative 240. So we get R cubed equals, I'm going to guess that that's negative 8, but let me go to my calculator. 1920 divided by negative 240. It is negative 8. And then we're going to cube root to get rid of the cubed. We get that R equals negative 2. Now let me show you a little bit more of an intuitive way to get it. If this formula is weirding you out, okay, a more intuitive way to get it would be like, okay, I know A4, then there's A5, then there's A6, and then there's A7, which is 1920, and this one is negative 240. Okay, so what we're saying is to get 1920, I would just take the negative 240, and I would have to multiply it by R to get from here to here. I'd have to multiply it by R to get from there to there, and I'd have to multiply it by R to get to there. So I multiplied it by R, I multiplied it by R, and multiplied it by R. So in other words, 1920 equals negative 240 R to the third. And you'll notice that matches, that we have the same exact thing, but it's just a little bit more intuitive, a little bit less formula-like, okay? All right, so we got the R, that's part of the directions, as it says, find R. So now we have to find A sub 1. So we're going to go ahead and use this formula to help us find the first term. Okay, so let me kind of scroll up a little bit. Okay. So if I want to find the first term, let me write down the formula. Okay, we know R now, and we also know the 4th term, right? R is negative 2. Now the 4th term was negative 240, so I'm going to go ahead and plug it in. So we should be able to solve this because there's only one unknown, right? This should give us A1. All right, so we've got negative 240 equals A1 times negative 2 raised to the third is negative 8. So to get rid of that negative 8, we would just have to divide by negative 8 since it's multiplying. And so we end up with A sub 1 equals 240 divided by 8. I think that's 30, you guys. There's our A1. Now, a more intuitive way, if you're a person who doesn't like formulas, we have A sub 4. What we want, A3, A2, what we want is A1, right? Well, we know that going this way to the right, that we were multiplying by negative 2, because that was the common ratio, right? Negative 2. Okay. So if I'm multiplying by negative 2 to go to the right, then I'd have to divide by negative 2. I'd have to divide by negative 2. And I'd have to divide by negative 2. So let's just take 240 and just keep dividing it by negative 2. So negative 240 divided by negative 2 would be positive 120. If I divide that by negative 2, negative 60. If I divide that by negative 2, positive 30. So that could be another way, it's a little bit more intuitive for how you could get. Now remember, we have to have these formulas though, because what if there's like a massive difference? Like what if, I had to divide by negative 2 like 20 times because it gave me like the 21st term, and I have to go all the way back to the first term. That'd be super annoying. And that's when the formula comes in as being something that I might want to use. Okay, so last thing we got to do is we got to write that expression for the nth term. So let me write the formula down. Okay, so a sub n equals, we now know a sub 1 is 30. We now know the common ratio is -2. So here is a formula that anybody could use to find any term they want. Okay. Okay, so we have, just like with arithmetic, we not only have a formula to find the nth term, but we have a formula to find the sum of the first n terms. So this is going to be the sum of a finite geometric series. Okay, it has to be finite. Notice r can't be 1, because that would give me 1 minus 1 in the denominator, which means it'd give me 0 in the denominator. We are not allowed to divide by 0. Okay, so let me go ahead and write down the formula. Okay, so we need the first term. So to find the first term, you're just going to plug in the lower limit. So we're going to substitute in 1. So we would get this. So 1 minus 1 is 0. Anything to the 0 power is 1. And then 3 times 1 is 3. So we have our a sub 1. It's going to be 3. Okay. Now, by the way, you have to ask yourself, how many terms are there? Well, from 1 to 8, that's going to be 8 terms. So we're finding the sum of the first 8 terms. Okay, so our n is going to be 8. Now remember, if they started at like 2 or something, subtract and add 1. Okay. 8 minus 1 is 7. Add 1 to it, you get 8. Okay, and this kind of seems silly on this one. But if they started at another lower limit, you want to know that. Okay, now the common ratio. So whatever's inside the parentheses is always going to be your common ratio. Okay, so the common ratio, let's write that out. And you know what? Let me actually do this. Okay, a sub 1, plug in bottom number. To find r, it's going to be the number in the parentheses. Number in parentheses. Okay. So in this case, that would be -1/3. Okay. All right, so we've got our r. It's going to be -1/3. We got to raise that to the nth, so raise it to the 8th, over 1 minus -1/3. Number one mistake is people don't put the minus minus. You got to have the minus minus because there's a minus from the formula, and r is also negative. All right, so let's get the sum of the first 8 terms. So the first thing I got to do is get -1/3 to the 8th. Okay, so you know what? I might just put this whole thing in my calculator, you guys, because it's kind of ugly and kind of gnarly. Let me clean up a little bit. I can clean up the bottom. This minus minus is going to become a plus. So 1 plus 1/3 is really 3/3. There's your 1. Plus 1/3, which gets us 4/3. So I know the bottom's going to be 4/3. Okay, so let me plug this in. Okay, so when I plugged it all in, I got 1640 divided by 729. Now I'm going to go and do it out for people who don't have good calculators. If you have a good calculator, just fast forward me, okay? So doing it out, what I would have to do is, I know -1 to the 8th power, since it's even, is going to be +1. But now I have to do 3 to the 8th power. So 3 to the 8th, I'm getting 6561. Okay. We already know the bottom is 4/3. So I'm going to turn the 1 into 6561 over 6561. That's 1. So 6,561, take away 1. That would be 6,560. And then the denominator stays the same when you're adding or subtracting with fractions, okay? Now, instead of dividing by 4/3, remember division is multiplication by the reciprocal. So I'm going to flip the 4/3 and make it 3/4. Okay. So let's go ahead and multiply straight across, you guys. I am going to put an over 1 here, and I'm just going to multiply all the tops. All these guys are going to get multiplied by each other. So I need 3 times 6560 times 3. Holy moly, I got a pretty huge number. I got 59040. Yeah. Then I'm going to do 4 times 6561. So I got this. Okay, I know 4 goes in, you guys. Could be that 8 goes in also, but let me start off by dividing by 4. If the last 2 digits are divisible by 4, then the whole thing's divisible by 4. So that's how I spotted the 4 quickly. Okay, so that gets me down to that. And then for the bottom, that. Okay. And apparently it goes even more. Gosh, what would that? Let me look at that. 7 plus 11, 13. I think 3, you guys. 6561 divided by 3. Gosh, does it go even more? Maybe it's 9. Let's see. Looks like 9 goes in. Okay, so if you have a calculator that reduces fractions, cool, you don't have to go through this madness, but I know some of you guys don't. So I'm going to divide it by 9, you guys. Okay, so 14760 divided by 9. 14760 divided by 9. Ah, winner, chicken dinner. Okay, I got 1640. And then if I do 6561 divided by 9, 729. There it is. Okay. All right. So that's the long way. Moral of the story, man, get a good calculator, right? Okay. All right. Find the sum of the finite geometric series. So S sub n equals a sub 1 minus r to the n over 1 minus r. Okay, so we know a sub 1. A sub 1 is going to be 3, right? So we could substitute that into the formula. And we even know the common ratio. It looks like from here to here, we multiplied by 2. From here to here, we multiplied by 2. So it looks like the common ratio is going to be 2. The thing I don't know is what the n is. Remember, the n stands for the number of terms. I don't know how many terms are in this sequence. So let's use the nth term formula. Not the sum, but the one that helps us find the nth term. Okay, so this is our side work. So off to the side, let's bring this guy back. And this is kind of common, you guys, where you have to use 2 formulas in one. Okay. All right, so I know the nth term. I know it's 1536. I know the first term, and I know the common ratio. I just don't know the n. So this will help us solve for the n. So first thing I'm going to do is divide the 3 out. So those cancel. So this is going to be 512. Yep. Okay. And then equals 2 to the n minus 1. Now it's been a while. I'm kind of glad we're bringing this back because we got the final coming soon. If you have the variable in the exponent, remember you natural log both sides. And that will bring the variable out of the exponent using that power property. So we have the natural log of 512 equals n minus 1's in the front now of the natural log of 2. All right, since natural log of 2 is multiplying, we're going to divide to get rid of it. So we have n minus 1 equals whatever the heck that is. So let me go to my calculator. Natural log of 512 divided by natural log of 2. I'm getting 9. It'll work for my pen. There we go. So then we just got to add 1 to both sides. Plus 1, and we get that n equals 10. So we know that's the 10th term now, right? We know our n more importantly. So we can go back and we can substitute that n. I'm looking for the sum of the first 10 terms. I know that the n is 10 now. 1 minus the common ratio of 2. So let's just draw a little arrow showing we plugged that guy in right there. Okay, so that was our side work. Let's continue on with this problem. Let's see what we get. So we got 3 times 1 minus, let's get 2 to the 10th. 1024. And for those of you with good calculators, just plug the whole dang thing in, right now. Okay, dividing by -1. So let's see here. This is going to be 3 times -1023 divided by -1. 3 times 1023. So it's going to get me -3069 over -1. So it looks like it's going to be 3069 for the sum of the first 10 terms. Sounds reasonable. I mean, I already have 1536 just for the last one. So imagine adding all the ones before that. Okay. So we also have a formula for the sum of an infinite geometric series. Again, I can only use this if the absolute value of r is less than 1. Do not use it otherwise, okay? If it's bigger than or equal to 1, then you would just say diverges. Okay, so only use this formula if the absolute value of r is less than 1. This deserves capital letters. Okay, I don't know why I can't write. There we go. Only use this formula if the absolute value of r is less than 1. Okay. I have students who will use it when it's greater than or equal to 1, and they'll totally get it wrong. Okay. We have to make sure that our series is shrinking in size. If the common ratio is like bigger than 1, like let's say it's 2, multiply by 2, multiply by 2, multiply by 2, forever, and now I say to you, add that up, well, that's going to head off to infinity, right? I mean, keep adding. This thing's just going to grow out of control and go to infinity. So I can't tell you what it adds up to. That's what we say. That's what we call diverging. So we would say this diverges. But if the formula is, if I'm multiplying by something that's, you know, instead of bigger than 1, like in this case, right? But let's say I'm multiplying by 1/2. Well, then at least it's shrinking. And at some point it's shrinking so much that you can kind of think of it as nothing. They're almost zeros, if you will, okay? So we want to make sure that this thing is shrinking. So I have an r less than 1. That's what's going to guarantee it's going to shrink. Multiplying by a fraction is what's going to make it shrink. So at some point, it's shrunk so much that it's like you're adding nothing. And that's the case when we can find the sum. This one converges. We can find the sum. Okay. All right. So let's go ahead and the formula is pretty close, by the way. I want you to notice if you compare it to the one we just learned, this is kind of cool. In fact, in Calc 2, we derive this formula from the one for a finite. And that's why they're so similar. Basically, just this part is gone and then they match. So very, very similar. So if you memorize this one on the right, you kind of have them both. Okay. All right. So it says find the sum if possible. That if possible means we've got to check that the absolute value of r is less than 1. So our r is the stuff in the parentheses, right? It's the number in the parentheses, just like before. So in this case, our r is going to be negative, oops, I don't need parentheses. It's going to be negative 3/5. So we always have to ask ourselves, is the absolute value of r less than 1? That has to be our question we ask before we proceed. Oops, I'm still in caps lock. Is the absolute value of r less than 1? Okay. So the answer to that is yes, okay? Yes. If I take the absolute value of negative 3/5, I get 3/5, and that's less than 1. Okay, then we're allowed to use the formula. Okay, so here's the formula. Let's write it down. So we know that we find the first term by plugging in the bottom number, 1. So our work off to the side here, let's find that first term. It's not always 1, it's just the bottom number, whatever the bottom number is. If the bottom number had been a 2, then I would have been plugging in a 2. So 1 minus 1 is 0. Anything to the 0 power is 1. So it looks like negative 6 is going to be our a sub 1. We already know the common ratio is negative 3/5. And I love this formula so much better than the last one. The last one's kind of a pain. Okay, so I'm going to make the 1 5/5. 5 over 5 is 1. And we're going to take the minus minus, and we're going to make that guy a plus. So this is going to be negative 6 over 8/5. Remember what that means? That means top, you flip the bottom and make it multiplication. So instead of dividing by 8/5, we're going to multiply by 5/8. And I'm going to put a 1 underneath and then just multiply straight across. So it looks like we got negative 38, which Connect Math's not going to take that. Cut everybody in half. There we go. That's going to be the sum. Okay. So it was possible. Now, on the test, how do I know I'm using this formula and not the other one? There's an infinity up here, which means it's an infinite sum. So this is the formula for an infinite sum. The other one's the formula for a finite. Okay. All right, let's write down our formula again. All right, hey, we got the first term. The first term is 4. Now the common ratio isn't like super duper obvious. Maybe people who have a really good number sense can see the negative 3/2. But remember, you just stacked the second number over the first number. So we would be stacking negative 6 on top of 4. You cut everybody in half. There's your negative 3/2. So you do have to include the negative sign. So this is going to be 4 over 1 plus 3/2. Minus minus, we'll turn that into a plus, right? Okay, so when we do the math, let's turn that 1 into a 2 over 2. So we can add 3 over 2 to it. So 2 over 2 plus 3 over 2 is 5 over 2. And instead of dividing by 5/2, we're going to multiply by 2/5. So again, put a 1 underneath and just multiply straight across. So that's going to get you 8/5. Now, for those of you with a good calculator, oh, you know what, guys? Holy moly. Shame on me. Maybe it's good that I did this. What? None of this should have been done. Maybe it's good that you see it because you're like, oh, you got an answer. I didn't even check. Is the absolute value of r, rookie mistake, less than 1? It's not, right? Shouldn't have done any of that madness, because if I take the absolute value of negative 3/2, I get 3/2. That is not less than 1, right? So we don't even need to do the math here, right? Okay. We cannot find the sum. The series diverges. Okay, so don't use that formula because you'll get something bogus. This guy's going to, head off to either infinity or negative infinity or oscillate or something, but we know we cannot use the formula unless the absolute value of r is less than 1. Okay, so this would be your answer. You could say not possible too, because I have the direction set if possible. All right. So I'm actually only going to do 11. I'm going to call it. This is something that we do in Calc 2. So you guys are actually doing Calculus 2 right now, which is kind of crazy. Okay. It says write 0.045 forever as a fraction. So 0.045 with the bar. We're going to write that as a fraction. So I'm going to just take out the 0.04. He's kind of like this term that I'm going to kind of ignore because he doesn't fit the pattern. And then I'm just going to try to write 0.5s forever, right? So here's how I'm going to do it. Okay, if I were to take this and add this up, 0.04, 0.005, 0.1230 zeros with the 5, 0.1234 zeros with the 5. And I add downward, right? If I add downward, I'm going to get a 5. I'm going to get a 5. I'm going to get a 5. I get my 4. I get my 0. Okay. So this really is generating what this is saying over here. When you put a bar over the 5, right? That means 0.0455555 forever, right? And that's what I'm getting right here. Down here, of course, the ... means you'd add more. Okay. All right. So this is going to be, I wrote it like this because we're on the section about geometric series, right? So I wrote a series for that number. Now, I don't like decimals, to be quite honest. I think it's harder to see what it is that you're multiplying by every time. And so I'm going to turn these into fractions. So I'm just going to use place value to do that. So if you go back to 4th grade, remember this first one's the tenths, then the hundredths, then the thousandths. So this would be 5 over 1,000. If I wanted to do this one, tenths, hundredths, thousandths, 10,000ths. If I wanted to do this one, tenths, hundredths, thousandths, 10,000, 100,000. And so on. Okay, put a comma here. So what I mean by I'm throwing out the 0.04 is that doesn't really fit the series. I'm claiming from here on, this is a geometric series. This is an infinite geometric series. Okay. You can tell what R is. Well, what did I multiply to get from 5 to 5? A 1. What did I multiply by to get from 1,000 to 10,000? Just added a 0, so it must be a 10. And you can check it again, so multiply by 1, multiply by 10. Did it work here? If I multiply by a 1, I'll get 5. If I multiply by a 10, it'll just add another 0. So this is working to get me a geometric series, at least for the part that I've highlighted. So we could find the sum of this. Since the absolute value of R is less than 1, we can find the sum of this. So in order to do it, we would have to use that formula, right? Okay, so let me kind of off to the side, draw a little arrow. We'd have to use this guy. So the first term would not be the 0.04. It'd be this, because I'm only looking at the part that I highlighted in red. So it'd be 5 over 1,000. And we know the common ratio is 1/10. So this is going to be 5 over 1,000. And if you think of the 1 as 10 over 10, right? Think of it as 10 over 10. Then 10 over 10 minus 1 over 10 would be 9 over 10. And so flip and multiply. 5 over 1,000 times 10 over 9. I can cross cancel. The 10 goes away and 10 goes into 1,000 100 times. So it looks like I'm getting 5 on top of 900. Again, just put this junk in your calculator, you guys. This is only for people whose calculators, don't do all this stuff. So just type that into your calculator, okay? Okay, so 5 over 900 is going to be the sum of this stuff right here, the stuff that we've highlighted in red. I still have to take I I didn't turn 0.04. I guess I should turn 0.04 into a fraction, tenths, hundredths. So it'd be 4 over 100 plus 5 over 900. You put that into your calculator. I'm going to just multiply by a quick 9. So this is going to become, scroll up, 36 over 900 plus 5 over 900. I'm getting 41 over 900 as the fraction that supposedly is 0.045 forever. I'm going to check. So in my calculator, I'm going to put 41 divided by 900. It says 0.0555555, and it just rounds up at the end and says 6. So this looks good. I checked it in the calculator and it did give us 0.045 forever. So you now know how to turn not just terminating fractions. Look at all these terminating fractions that we turned, or decimals, I'm sorry, terminating decimals that we turned into fractions. But now you guys know how to take a decimal that repeats and turn it into a fraction also. So you've added something new to your little tool belt for things that you can do. All right, you guys, I'm going to go ahead and call it there. And that was our last section. Thanks for all your hard work. And hopefully 8.3 is a nice, easy section for you. All right, take care, guys.